Hello all, my name is Krishna and welcome to my YouTube channel. Now in this particular video, many of you are basically requesting me to create a video on Kaggle competitions. So what I have done is that, as promised yesterday, right, I have actually done a Kaggle problem statement in within 4 to 5 hours, and I completed it. I have submitted it in the Kaggle website itself. So I'm going to show you that problem statement, what I have done, but still it is just in the initial stages. I need to hyper tune it more. I have to apply a proper algorithm to it, try to play with each and every parameter still. But apart from that, feature engineering, feature selection, and a simple model creation has been already done. And the rank is also good, which I'm just going to show you. And the best way to start is that I found out Kaggle competition, which is named as House Prices Advanced Regression Techniques, and it is ongoing. So that is the reason why I've taken this particular example, and I'll show you with the help of a very good things that. So basically, I'll try to show you what all you have to do in Kaggle. What is Kaggle all about? I'll introduce. Initially, I'll try to introduce you to Kaggle, what Kaggle is all about, how the data set is basically present, how you have to program, you have to write the programs, and after writing the programs, once you get your output, how do you have to submit it so that you get a ranking in this. So let us begin. So I'm going to take this particular problem statement, which is called as House Prices Advanced Regression Technique. So inside this, you just have to, first of all, you have to log in. Make sure you log in. Without logging in, they'll not allow you to basically download the data set. So after you log in, this is the description of the project that you will be seeing. Okay, all the information are basically given, what all things are there in this particular data set, how the evaluation technique is done. So on what parameters they are going to calculate the accuracy, how is the submission file format. I'll just tell you about the submission file format, and again, there are tutorials, there are a lot of informations about different Kaggle competitions also in this. Now the main thing is that just go to the data, click into the data, and now here you will be able to see that how many data set you basically have. So here you can basically see what all files they are. They are like test.csv, train.csv file. There is also a data description of this particular file. If you want to see some more information what all this particular file consists of, remember guys, this train.csv is basically your training data. So you have to train your model on this particular data. After training, you basically have to predict for this test data. Okay. And then after you do the prediction, whatever output you are basically getting, you have to submit in this sample underscore submission.csv. The one common thing that you'll find between this sample underscore submission and test.csv, over here, whatever ID, which is your unique identifier, that will also be present in this particular sample underscore submission.csv. Let me just take an example and show it to you. So first of all, we'll go and try to see what the training data basically consists of. So I'll go and click over here. So just give me a second. Okay, now here is my training data. You can see over here the whole complete training data is basically over here. How many columns you have. This first one is basically your ID. You have different features. And again, about this particular problem statement, guys, this is housing price advanced regression technique. You need to find out the price of the house, okay, based on various features that you can see over here. Okay, and it has literally around 81 features. It has literally around 81 features, and there are many categorical features. There are a lot of null values, how you're going to handle that. A lot of things will be basically over there, and you need to do a lot of stuffs in this. So I've taken this particular problem statement so that you'll get a complete idea about it, how it is done. Now the next thing is that after I go over here and see about the training.csv, you can also see test.csv. I'll just go and show you how does sample submission file.csv look like. So this is the ID of the test data itself, and this is the output that you have to predict and give it to them. Okay, so after you make this kind of CSV file, you have to just submit in the predictions, and that CSV file you have to just upload it. Once you upload it, you'll be getting a score. Based on that particular score, you will be basically getting a rank. Now, as we had already seen in the evaluation technique of this, you can see over here in the evaluation. Here in this evaluation, they are basically saying that they are going to use root mean squared error, okay, RMSE. So if you know about root mean squared error, it will basically come in decimal values, based on that particular decimal values only, and that you cannot see it, you cannot directly calculate it. All you have to do is that you have to make that submission file format, and you have to just submit in this particular web page itself after clicking the submit predictions. Then only you will be able to see. Now in the leaderboard, if you see, there are so many people who have actually got very good ranks. You can see 0.05, 0.08, 0.099, and one of my, if you see my rank currently is 2521. So I'm getting somewhere around 0.141. And this is just, I have written the code in 4 hours, guys. Understand that thing. Still, I have not done hyperparameter optimization. And this will take time. It is not just a 4 hours work. Okay. So after getting the first, this was my first trial. I have uploaded it. I've got a very good score, what I think. Because you can see over here, more than 4,500 people are have participated. So somewhere around 4,384 people have participated. And yes, I was able to get 2521 just in my first attempt. Now, again, this is just not my first problem statement that I've solved in Kaggle. I've solved many, but I've just giving you an example. In this, I have not applied any hyperparameter optimization. I've just followed a feature engineering, all the feature engineering work I have basically done. I've done all the feature selection. But again, let me just show you what all code I have basically written over here. So you have to just go to the data and make sure that you click on this download all button. Okay, so once you download it, you'll be downloading all these whole files. You can just click on download all the files will get downloaded. And let us go and start how we can basically solve this particular problem statements. Okay, so to begin with, what I've done is that I have imported NumPy, Pandas, Matplotlib, and Seaborn. And there is a reason why I've done this. I'm going to do some analysis later on, but not right now. In the initial stage, how I've basically solved this problem is that I've just handled the missing values. I've handled category features. I've handled, some of the features, which features I have to drop. Okay. I've just done some of the things like that. And after my next stage, after now I know what is my score. Now, in order to make it much more better, I'll be doing a lot of steps, which I'll be showing in my upcoming videos. But currently, how I got this particular accuracy, that I'm trying to show it to you. So here it is. I'm uploading the Trainload Csv file. And this is my dataset head, which I see over here. There are around 81 columns. Okay, 81 columns, and they are somewhere around 4,000, not 4,000, 1,400 records, I guess. Let me just have a look. Okay, so I'll just make a cell above. Okay, so here you can see that it is 1460 records, 81 columns. Okay, and this particular code is basically to see the this sns.heatmap, df.isNull, why tickable false. This is basically helps you to see the null values with the help of heat map. Okay, I'll show you all the examples. So let us see. Initially, I have this shape. Okay, and what I can do is that I can use a function called as df.isNull.sum. Okay, so first of all, let me just execute it once again, so I can show you by executing it in front of you. Okay, so initially what I did is that I just tried to see. And always remember, initially we should also always see that how many null values are basically present. So if I execute, okay, it is giving me some error. Has no attribute sum. Okay, sorry. So this should be a function. I'm writing it as .sum. Okay. Once I do this, you can see that there's a whole lot of features. Whole lot of features where you are basically getting a lot of missing values. So in lot front age, which is a feature, they are around 259 missing values. In alley, they are around 1369 missing values. And similarly, if you go down, there's something like fireplace queue, garage type, garage year belt, garage finish. All are like more and more number of features. Here you can see pool QC, fence are so big numbers, 1453, 1179. So what I've done for all these features that are having very number of large number of missing values, because just understand, guys, the total number of records that we have is somewhere around 1460. And if I take this examples over here, 1453, 1179, 1406, so many missing values are there. So what I've done is that I've planned to drop all these columns, pool QC, fence, miscellaneous features, because it is not necessary to do that. I'm not dropping this. Okay, not this also, fireplace QU. But instead I'm dropping which is having more than where your missing values is more than 50% at least in that particular record. So I'm dropping those. So I'll drop in the future. You'll be seeing I'll not drop lot front age because there's just 259 missing values, but I'll try to see what I can do for that. So initially this was the problem that was basically happening when I was trying to solve it, and it was not easy, guys. I have to do a lot of things. There were like 81 features. Now just if you have 81 features, it is difficult to just understand directly which, without any domain expert knowledge, right, which feature to drop, which feature to not to drop. So for that, what I've done is that I've dropped features like alley and some more features which you will be seeing towards the down, where my missing values is more than 50%. Like this kind of features, I've deleted it. So what I've done is that after that, what I'll do, I'll go and see what is the heat map. Now you can see this in this particular heat map, the white line basically shows that these all are missing values. Okay, these all are missing values. Now based on this, you can also tell me that, okay, I don't require this pool QC miscellaneous value because there's so many missing values in this, and definitely it is impossible to predict directly, right? It is very, very difficult. So what I'll do is that wherever I have this kind of situation, I'll be dropping this columns itself. So let us go ahead and try to understand. So initially my shape is around 81 features. Now lot front age, you know that lot front age, if I go and do a df.info, just see this. If I do df.info, if I execute it, you can see that my lot front age is basically a floating value. Okay, float 64. Now there are also lot number of null values over there, and what I have done is that initially, without judging anything, without understanding about all the features, I've just taken the mean. I'm telling that fill all the NA values with the frontage mean. Okay, that same column mean, and I've basically replaced the missing values over here. Okay, now always remember, guys, you should go line by line. Okay, you should go feature by feature. Now since we have 81 features, and obviously you'll get confused, to make sure that first of the feature you target one feature like lot front age, then you go with respect to the other features. Okay, so that is how I have done. Otherwise it will be very, very difficult. And one more thing that you have to do simultaneously, you try to handle the test data also. You have the test.csv, and remember, all the feature engineering that you're doing for training data, you also have to do it for the test data. Okay, so simultaneously I'll go and execute my test data. I'm going to read my test.csv. So this is my shape. Why the shape is 80? Now see, in my training data I have shape as 81, right? 81 features. And remember, this sales price over here, you have if I go and show you my data set over here, at the end of the column there will be something called as sales price. Now this sale price is basically a dependent feature. You need to find out this particular value based on all the other features, price of the house with respect to all the other features. In the test data you will not have that. In the test data you will not have that. Okay, so don't worry about the code, guys. I'll be giving you this particular code in the GitHub, so you can basically do a lot of stuff with this. Okay, and try by your own, try to do more extensive things. Now I'm again checking over here test data frame.head, and if I go to the last column, you see that I'm not having that sales price. In this case I had sales price, right, before after sale condition. So after that, what I'll do, I'll also go and check the null values over here. Now see, in my previous stage you could observe something, right? When I check the null values over here, right, you could see that my leverage, my MS zoning did not have any null value. Whereas over here in my test data set, MS zoning is having some null values. Okay, now this is again, you have to, so I'm telling you, you have to simultaneously work along with test data and train data both. Okay, now for MS zoning, let us understand what this MS zoning column is all about. If you go and see over here, MS zoning is basically an object type. Object type basically means that is basically a categorical feature. Okay, so if you go and see the data set dot head, and if I move it over here, you can see this MS zoning is categories. There are around 3 to 4 categories like RL and all. If you want to basically see this, you can just write it as df of MS M capital S, and just press tab, you'll get it. Dot you can basically use, I think you can use value underscore counts. Now let's see whether this will get displayed. Now here you can see that value underscore counts basically gives you 5 categories within them. So what you can do is that in order to handle the null values over here, okay, what I have done is that I've basically taken the mode of these categories. Now mode basically means that which is your most frequent category, that will get replaced by that. Okay, so you will be seeing that that will be my first step that I will do over here after I have actually done my frontage mean. So I've already shown you, I'm going to compute this frontage mean, right? So I'm going to do this frontage mean and I'll go execute it. So I'm handling all the NaN values of lot front age column where I'm handling the missing values by replacing it with the mean of it. Okay. Then I have df.drop alley. Why I'm dropping the alley column? Again, guys, there is so many number of features that are having null values over there. So that is the reason I'm just dropping this alley column. Okay. So make sure you do this, and simultaneously we'll go back to the test data. Now in test data also we are doing this, and again now see in that in the training data we did not do anything with MS zoning, but here we are performing the mode of it. So in order to perform, I'm just writing test underscore df ms zoning dot fill na test underscore df ms zoning dot mode of 0. Okay, mode of 0 basically means it will take the mode of that particular column and it will be replacing for on all the nan values. Okay, and remember guys, first of all I'm handling the missing values. I have to handle the missing values. Okay, that is the first step in feature engineering. Then only I can decide something else. Now after that I'll go back again to my final project over here, and you can see over here what all I have done. I have actually, again guys, you can all write one inbuilt function, one custom function where you can write all this code, but I was going, you know, feature by feature. I was just seeing features by feature and I was trying to solve this particular problem. So you'll be seeing that wherever I saw that the feature were category features, I have just replaced it with the mode. Okay, because I'm not analyzing it in the initial stage. You should never do that. Okay, you should try to understand about the data, but later on, see, now I have actually submitted. I know what is my accuracy. Now I have to try to reduce that particular error that is basically coming over there, right? Now in order to do that, what I'll do is that I'll start exploring more about this particular feature. But currently I've just taken the mode of all the category features, I have replaced it. So that is the reason you'll find for all these features which are basically category feature, I'm replacing the nan values is mode of 0. If it is more than 50%, I'm simply deleting it. So you can see over here, I will be executing everything like this directly, but make sure you go feature by feature. Again, see guys, the first feature that I went was with MS zoning, right? Because this was having null values. Then I went with lot frontage. You have to go just by feature by feature. Now you found out that alley, the number of missing values of more than 50%, I have dropped it. In order to drop it, you can see I have written a code over here also. I've written a code over here, right? So similarly, I'm dropping pool QC fence miscellaneous features with access is equal to true. Now this is done, and now you can basically see my shape. This is my shape. I'm also dropping the ID column because ID is unique identifier. I don't require it, so I'm dropping it. Now if I go and see my summation, you can see that now I'm having very less number of null values. Only in some of the features I'll have. So in here I have basically having 8 records that are having null values, 8 records. Here also for this particular feature we are having null values. So I go down, I don't see any null values then. Okay, so I'll be handling this too also. Now what I'll do is that I'll again create this heat map to see, because again there's so many features and sometimes I may miss some of the features that are having null values, like this feature which are not visible over here, right? So for that, what I'll do is that I'll just create this heat map and let's see whether there is some null values. Yes, you can see some of the null values over here, right? This color is basically null values. So in order to handle that, I know my column where the null values is present. What I'm doing, I am basically making again the mode. Again, that is the category features. Then again, I'm trying to see with respect to this heat map. Again, I see there are some null values. Okay, now you can observe that there are very less number of null values remaining. Okay, so again I've done for one more feature, and finally what I'll do is that after executing this line, you can again, if I go and click over here, you'll be able to see that there are very small number of null values, around 8. Okay, so what I can do is that I can finally drop the records if I want. Okay, because there's very less number of null values for that particular feature, I can simply drop the records, or I can also find the record and try to use the mode similarly. Okay, so I have done this. Now you can see my shape is 75. Now my df.head is over here. Now what I'll do is that I will go and create this columns. Now see guys, I have handled all the missing values here, right? Till here I have handled all the missing values. I know that my handling of the missing values is based on mode, and for integer variables I have done it with the help of integer mean, right? But now why I have done that? Because I just want to start with the problem. Okay, I have still not done any statistical analysis. We will do that in our next section, because I know my accuracy over here. Now I have to make that accuracy better. Now after that, after handling the missing values, now I go and I have to handle all the categorical features. So I'll write down a comment over here so that you'll also be able to understand. Handle categorical features, right? I'm going to handle category features, and there are various ways of handling category features. So first of all, what I did is that I made all the note of all the category features, and this all category. One lucky thing about this particular competition is that these all category features are basically having just 2 to 3 or 4 categories max. Okay, so what I thought of is that can I write one function wherein I will be considering, I'll be taking this category features, I'll apply a get dummies, pandas.get dummies in order to convert the category feature into dummy variables, and then I'll append that same variables directly to my data frames, right? So that is what I was planning to do that. So for that, what I did is that I started creating a separate list of all the category features. So this is my list of category features, and I created one column. Now, if I go and see the length of column, there are 39 category features in that 81 columns, Now I created one function which will be handling all the features and converting that into category feature. So this is basically my function. Okay. And this is my function. After converting, you just have to provide the list of columns here, and then it will be returning you all the category features directly into this. Okay. Sorry, all the data frames concatenated with the category features, because you can see over here I'm concatenating it. Okay. Now after that, after you do this, right, make a copy of your data frame into one variable. So it is always good because this value should not be getting changed again and again. Now after doing this, okay, what I have to do is I have to run this function, right? I have to run this function. I have to run basically this function. But before running this function, guys, I observed one more thing, one more problem statement. Now this all same method, this all things that I have done over here, I also have to do for my test data. Now for my test data, when I was doing and when I actually saw some of the features in test data, what was happening is that in some of the features, they were multiple categories, and those categories were not matching this training data. That was the problem. Let me just give you an example what I'm trying to say. Suppose consider that in one of the column that I have, like this column BSMT condition. Suppose this is a category feature, and in my training data set I just had 3 categories. Okay, I just had 3 categories, but in training data, in test data, for the same field I had 4 categories. Now just understand, if I am using get underscore dummies, I will basically be create for that 3 categories, I'll create 2 dummy variables, right? Whereas in this particular case here, I'll be creating 3 category variables. So what, since we don't know in the training data set that whether we are having the complete whole some categories, what I have done is that I will take this test data, concatenate with the training data. Okay, concatenate row wise with the training data. Just understand this very important thing. So what I'll do is that, first of all, the reason why I'm concatenating is that after concatenation, right, after concatenation, you can see over here I've written the code. Okay, I'll just tell you about the code in a while. So after I concatenate, now I'll apply the pandas.get underscore dummies, which converts into a one hot encoding to the entire column itself. Now if I combine both training and test data set, I know that I have all the specific number of categories within each and every feature, and it will never increase after that. Okay, so that is the reason why I will combine my training and the test data. Now before combining that, I have to perform all the operations that I have done to handle the missing values, like how we did it in the training data set. So that is why I have created this different file. Now you can see over here I have done all these particular steps, you can see that I have applied mode for everything, all the categories to handle it. And why I have applied mode, I've just seen, guys, because there are around 3 to 4 categories only, and there are some missing values which I'm planning to replace with in mode. I'll try to have a look. I'll try to see to have a look whether I can change this or I can replace with something else. But currently I've just selected as mode. Okay. If there are integer variables, I've basically used mean. Now after this, what I do is that after handling all the null values, I will convert this into a CSV file, so that this CSV file is stored after handling the null values, in short, because I have to combine the data from this test data set into my training data set, so that I can apply my one hot encoding, right, by using pandas.get underscore dummies. So here, after executing this file will get saved in my same local folder wherever I'm executing. Now you can see over here,
when I go to my training data set, okay, till here I've already explained you. I've taken the column of all the categories. I've created a category, a function which converts a category variable into one hot encoded. Now what I'll do is that I will go and read that same formulated test.csv. Now you can see that my test.csv is basically having 74 columns and this many columns, this many rows. Okay, and this is how my test data looks like. Now what I'll do, I'll combine my train data which is present inside my df and my test underscore df. Okay, row wise, I'll try to combine it row wise. So in order to do that, I'll just write pd.concat df comma test underscore df with axis is equal to 0, and that variable is basically stored in our final underscore df. Okay, now when you go and see this, my final underscore df dot shape is somewhere around 2281, which is the combination of both training and test, and my records are 75. Remember, in my test data set, I don't have a column called as sales price. So if I'm concatenating for all my test data, it will have the nan values. You remember that. Now I can easily apply my this particular function which converts all my category features into one hot encoding. So for that, I'm just calling this function over here. Okay, and I'm giving my list of columns over here itself. Now here you can see that for which all columns it has basically performed it. Okay, now after performing this, you will be seeing that I will now have 235 columns created from that 75 column after applying one hot encoding. The last final part that I want to do is that I'll remove all the duplicate columns by this particular code, because I don't want any duplicate columns. See, if any duplicate columns are basically there, that basically means that both are internally correlated, right? And both are having the same importance. So I'm just deleting the duplicate columns from this, and my final df is basically created. And now you can see that my final df is basically having 2881 records and 175 columns. Initially, how much columns I had? I had 235 columns. Now I have 175 columns. Okay, so this is how I have basically done. I've converted into a category feature. Okay, now if you want to basically see my category feature, I can also show you that. So let's go and see this. So this is my final underscore df dot head. Let's see. Now this is how my category features look like. You can see that if I go to the last, you all have values like zeros, ones, zeros, ones, zeros, ones, and all. Okay. Now again, what I'll do, I'll divide this into my training data set and test data set. Again, I know how many records were there in the training data set. I'll take that much. How many records are there in the test data set? I'll take that much. My test data set, I'll drop the sales price column because I don't have any. All the values are nan over there, and my axis is equal to 1 in place is equal to true. I'm doing that. Now you can see my shape in my test data set. It is 1459, 174. Now what I'll do is that I will drop the sales price for my training data set in my xtrain. I'll just, from this training data set, I'll create my xtrain and ytrain, right? So xtrain is basically having sales price, drop all the columns apart from sales price. Ytrain is basically having only the sales price. Now what we need, we have our xtrain and ytrain. The best thing is that you start applying algorithm. Now here I've just selected XGBoost. I could have also selected random forest, but I want to try with random forest, XGBoost with hyperparameter optimization. But initially I just wanted to try it out. I've used XGBoost regressor. I've done this and this has got executed. My ensemble techniques over here. I was trying for random forest regressor, which I'll do it later. So once your function gets executed, once your classifier gets fed, you can also save it as a pickle file, so that you don't have to train it again and again, because the training will take some amount of time. And after that, what you do is that you just use classifier.predict on your test data set, and now you'll be getting your ypred. Okay, so this is your prediction data set. Now this particular data set, remember the submission.csv file. Okay, so what I'll do is that first of all, I'll convert this ypred into a data frame. Okay, then I will read the sample underscore submission.csv file. I will take the ID column from this sample.submission.csv. If you remember, guys, we inside this particular data set, right, we have an ID and sales price. I don't require the sales price. Sales price, I have actually computed it. I will just take this ID column. I'll put up my sales price over here. So for that, I'm writing this 2 lines of code. And finally, I'm converting this into sample underscore submission.csv. Now after that, once your submission file gets created, you just have to go over here, click on submit prediction. Then they will ask you the file to load over here, you just have to click over here. Then what you have to do is go and select your sample submission.csv, upload it. That's it. After uploading it, write the description over here and do make submission. As soon as you do the make submission, it will go and compute the score, and you will be able to see your score over here in the leaderboard section and whatever rank you're getting. Okay, so currently you see that I am getting somewhere around 2522 rank. I'm definitely sure I will be able to come into top 100 because I have to do a lot of things over there. Some of the best practices that I will definitely follow, and I'll also give you the suggestion how to do it in my later videos. But right now I've done till here. The best thing is that I was able to do this in just 4 hours. And that was the most motivating thing for me. I had to do a lot of stuffs, understand how that training data was, how the test data was. Remember, this becomes difficult as the number of features increases. I've just not selected only some specific features and performed this particular operation. Instead, I've selected all the features and I've tried to do that. So I hope you like this particular video. I'll be sharing the code along with this both file, which you can basically do it, but make sure you download the dataset from here and try to upload it. Okay, try to do something new in that and try to upload it. So I'll see you all in the next video. Have a great day ahead. Thank you one and all, and have a wonderful weekend. Thank you guys.